results. Now let's consider an example like this. Suppose we have an original function, and assume that we have Laplace transform of as the power of, we have a, maybe you still remember, we have a formula like this. So let's try to verify whether it holds or not. Suppose we have a function like this. How can we find the Laplace transform to the first order derivative of the original function? And what is its relationship between the result and this function? So let's answer the first question. What is the Laplace transform? If you have already an f function, then you can easily find the fifth order derivative using a function like this. So the derivative first and then take Laplace transform, and then call the simple function to simplify the result. And this is the result. Simplify the result. And then we need to find the Laplace transform of st and multiply it by s to the power 5. So what's the difference between them? Is the difference between them 0 or not? We can find the result and find the error between them is not 0. So why it is not 0? Initial condition, yes. So you must be very careful with the initial conditions. If the initial conditions are all 0, it is fine. If they are not, then the difference may not be 0. So you must be very careful. Sometimes this kind of phenomenon will be neglected, but you must be very careful how to solve the problem. If you take into account the initial conditions, the result will be consistent. Another question. Can you still memorize the formula I showed earlier about the nth order derivative and then take Laplace transform? What is the formula? Can you remember whether it is Sn minus 1 times s0 or n to the minus 1 s times 0? Which one is correct? I always mix up on this formula, so don't worry, I will try to derive or display the formula by Matlab. So what is the Laplace transform to the second order derivative? To solve this, first we need to declare a variable like this. It is perhaps not easily understood in the syntax or in grammar, but it is useful in Matlab formula derivation. And in the assignment, I think I gave you one of the examples like this. Declare that y equals to ft, which is a function here. So what we need to do is to take a second order derivative of y with respect to t. And then for the result, we can take Laplace transform and see what we get. So the result is something like this. We have I squared times we can use this one as fx times the first order derivative, initial value of first order derivative minus s times f0. I think you can understand the syntax. So if we change 2 into 5, you will see what the formula is. S to the power of 5. And then we can denote the Laplace form like this. And then minus yes, and then so we can recall the formula like this. So if you cannot remember, if you cannot remember this formula, in fact, it's quite difficult to memorize. If you cannot remember the formula, you can easily rewrite it by making use of Matlab function. And this one should be very simple. If you have a function, then you can take the first order derivative. I'm not going to demonstrate it again. Take the first order derivative and then call the Laplace function. Finally, you will get the result. And if you are interested in the collective form of this polynomial, you can call the collect function. And this is the final result you normally obtain.